Hello, today we're looking at constructing triangles. Now, constructing is a formal word in geometry and it means to draw accurately. So when you see construction, you will need a protractor, a ruler, a pencil, and for some of these later on in this unit, you will also need a pair of compasses as well. Now, the two that we're looking at today are angle side angle triangles and side angle side triangles. Now, these are regularly in geometry abbreviated to ASA and SAS, where A's and S's are short for angles and sides. So when you're doing these, an angle side angle triangle means that you will be given the angle from one of the corners, the side from another one of the corners. You will then be given another angle, but we do not know the length of this side, we do not know the length of this side, and we do not know the turn of that angle. Similarly, with side angle side triangles, we will be given the length of the side, we will be given the angle, we will be given the side, but again, we won't know that side, we won't know that angle, and we will not know that angle there. So we're essentially given three pieces of information and we can then draw the triangle from this. However, be warned, not all permutations of side angles and sides will work. We will come on to that later on in the unit. So first of all, in these questions you will be given a triangle to construct. So I am telling you that this angle, the triangle that you will be constructing, is one with an angle of 40 degrees, a base of 8 centimeters, and then another angle of 60 degrees. So this is an example of an angle side angle triangle. Now, as you can see, I've done this as a very quick freehand sketch. Okay, I know that that is going to be an acute angle. I know that is going to be an acute angle. Okay, so immediately I can start to see there's some sort of pattern forming here. If that's an acute angle and that's an acute angle, that one must therefore also be an acute angle up here, because just doing a quick bit of mental arithmetic, 40 and 60 is 100. So that's got to be less. But it's no good saying, oh, well, that's got to be 80. We're not asked for that. When we're constructing triangles, they're looking for certain key skills. So when you're constructing a triangle, start off with the baseline. Now, it's much easier to do constructions on a plain blank paper rather than in your squared maths book. So each one should take up approximately a quarter of a page on A4. Sometimes you might need more, you might only fit 2 to a page, but don't worry if you feel like you're using lots and lots of paper. This is one of the times when having lots and lots of paper is an advantage. Right, I'm just going to push this up a little bit. There we go. So what I'm going to do is I'm going to start off by drawing the base. The base is 8 centimeters, so I'm going to draw that base accurately. Okay, and as I draw, I label. I'm now going to do this angle here. So I need to turn the line from the pivot point by 40 degrees. Now, exactly as you did last time, you're going to measure the angle. So the cross goes on the end of the line, the baseline goes on the baseline. I'm then going to count up 10, 20, 30, 40 degrees. Okay, mark it on, and then I'm going to join it. Now, this is a construction line, and you never ever rub out construction lines, okay? Right. Oop, got to label it. Now this corner here we are told is 60 degrees. So again, same principle. I'm going to this pivot point here. This angle will be 60 degrees. So again, I line it up exactly. Cross on the cross. On. Mark on 60 degrees. And then going corner to corner. And that is 60 degrees. Now, in mathematics, these two parts here we leave on. These are our construction lines, and an examiner is looking for the little pencil markings to show where you've measured it to, and they expect you to start again. They expect these to overlap. They expect them to intersect and cross over. Now, if you're doing formal drawing, graphics, architecture, etc. by hand, then it would be expected that these crossover lines would be rubbed out, but in mathematics you leave the crossover lines there. Okay, let's do another example. Again, another angle, side, angle, triangle. This time I'm going to do one which has a 5 centimetre base. It is going to have a 25 degree angle there, but this time I'm going to give it a 125 degree angle there. Now, this sketch is not perfect. I've had to extend it up there, but I've got an idea that I'm expecting it to skew one way. So when I'm deciding where to draw it, I'm going to move it over. If when you're drawing them, you go off the page, you might need to restart. Okay, don't rub it out. This is all part of your learning. And if you can see where you went wrong the first time, the second time it may be easier. So again, she says picking up her pencil, it seems to be in a little world of its own. I'm going to start off with a 5 centimetre base, and I'm going to come right the way over here so that I've got plenty of room to draw over there. Again, as I go, I label it. Cross on the cross, 25 degrees, 10, 20, 30, come back 5. Mark it on. Now I know this is going to be quite a long line because this is in fact going to be the longest line. So I'm going to do it quite long all the way over to there. Hopefully that will be enough. And that is an angle of 25 degrees. Oops, hold on. Alarm's about to go off. This angle here is going to be 125 degrees. So again, pivot point on pivot point, base on base, going from 0, 20, 30, 110, 120. There we go. Didn't need to draw that as long as I did. but doesn't matter. You've still got all of the key information there. So these are two examples of constructed angle, side, angle, or ASA triangles. Right, let's have a look at side angle, side triangles now. Excuse me, clear my table. So, again, you'll be given the question, you'll be given a sketch, and it is always worth re-sketching it onto your working paper so it gives you an idea of what you're doing. When I sketch, I'm not using a ruler, I'm just making a small, almost thumbnail. So the first one I'm going to do is a side of 7 centimetres, an angle of 70 degrees, and the other side of 5 centimetres. Now clearly when I've sketched this, I've drawn the 5 centimetre base larger than the 7 centimetres, so I'm just going to extend that out a bit more so I get a better idea of what it might look like. Okay, let's go. Now with these, you always start from the base line. So we're going to start off with 5 centimetres, drawing accurately. The angle we're measuring is 70 degrees. So again, pivot point on pivot point, base on base, from 0, 70 degrees. I've gone on to my sketch. That doesn't matter, but it's clear where I'm marking to. And then I'm going to draw in the line. However, this line only needs to be 7 centimetres long, and because of the size of my protractor, it is clearly too far. Sometimes when you do these, your protractor will not be far enough, so you will then have to extend it out. But either way, you are going to measure accurately. Now, some practitioners say, well, you've got a ruler measured in centimetres, therefore you can measure it accurately in using the ruler. Some people like to use a compass and mark it. Personally, if you can measure accurately, a ruler is enough. Right, so 7 centimetres, line it up, pivot point on the 7, bring it round, and I'm going to mark on where 7 centimetres is. I am then going to take that up to the 7 centimetre line. So, oops, move over again, so just go over it. So we have the side of 7 centimetres, the angle of 70, the side of 5. Side, angle, side. Okay, final one. Oops, I'm going to construct. So right, I'm just reading my notes where I've written down what I'm doing. We're going to have 8 centimetres, 14 centimetres, and the angle I'm going to do there is 135 degrees. And again, I'm just going to not make it a perfect sketch, but if I've got a good idea of what's going to happen, it gives me an idea. So that is going to skew off that way. Again, the more of these you construct, the better you will get. So, as before, start off with the base. Now, because I know it's going to skew off that way, I'm going to come right over here. Start off with 8 centimetres. Again, write it in as you go. I'm then going to have an angle of 135 degrees, always the same, pivot point, pivot point. Okay, and what you will note that as I'm doing this in real time, I'm checking it carefully as I go. Baseline, baseline. Counting up. 130, 140, 135. Marked it in there. As it goes. Again, this time I'm going to measure it accurately to here. And as I suspected, you can see I'm going to have to extend it out. Now it's sort of crashed into my other diagram. While I'm learning what I'm doing, that's absolutely fine. Obviously, if I was a professional engineer and I needed these exact scale drawings, I'd have it looking neater. But while you're learning the skill, that's absolutely fine. So to recap, that angle there is 135 degrees. That line there is 14 centimeters, and we are constructing triangles, so we will have to finish that triangle. Now if you don't have the right sized ruler, trying to judge on here is not easy, but what you can do, you can use the straight edge from your protractor and the ruler to extend. Now it won't be as neat as if you've got a 30 centimeter ruler, but it will give you, as you can see, that's way off, it will give you better than nothing. There we go. There is my triangle. Now obviously I can't give you your own ones to go and do now, but please go back and construct the 4 triangles I've constructed. Like I say, plain paper, pencil, protractor, ruler. Have a go and see if you can make them look as good as mine.